Alright, this is the second video of Chapter 9, looking at representing linear inequalities. Remember that last video was looking at graphically or on number lines, and today we'll focus on algebraically. So, in order to do that, we need to remember our greater than, less than signs. So, remember way back when, sometime in elementary, when you're first introduced to these concepts, greater than, less than, I would imagine your teacher might have talked about something like hungry alligators or sharks or something like that. I remember that's what my teacher did. Talked about alligators, and the alligator was hungry, and therefore the mouth is going to open towards the bigger side because it wants the biggest meal. So I find that a really helpful picture in determining which one represents which. So we've got our greater than sign or our less than sign, right? Which means that the greater than sign, that's going to be opening to the bigger side here, right? And over here the less than is the bigger sign is over there. Okay, so we are going to go through just a set of examples here and make sure that we've got these signs nailed down. So in order to do that, we've got a list here. We've got the first one, A is greater than B. Well, the way we would read that is A is greater than B. Okay, so same thing, left to right, just how we would read anything. A, and then it's the greater than, which means that's the erase that. That's going to be confusing with one later on. But it means that the alligator mouth is open towards the A. That means A is greater than B. Okay. Then we've got A is less than B. Well, that just means that the sign is going to be opposite. So again, you read from left to right, A, and then the sign is less than because it's pointing to the opposite side. It's pointing to the B, or it's opening up towards the B. Okay. Now then we could do A is greater than or equal to B. So A is, and just like what we had before, greater than B, but now we've got this greater than or equal to, and so in order to make that work, we put a little line underneath. Kind of looks like a little bit of an equal sign now. That's the idea. A is greater than or equal to means that it could be equal to B. And then we've got A is less than or equal to B, and finally A is not equal to B, and that's just an equal sign, and then you cross it out to show that it's not equal to B. Okay, so those are the basic signs that we use in these algebraic expressions. So we're going to go through a bunch of different examples and we'll see how we're doing. So write an algebraic linear inequality that represents each of the following. So all numbers up to and including 17. Okay? So 17 is our boundary point, and all numbers up to and including. Okay? So that means those are going to be the numbers that are smaller than 17, right? Which means 17 is going to be the bigger number. So the numbers we're talking about, we're going to represent with x, and 17 is bigger than all of those, but it also says it includes 17, which means it's going to be 17 is greater than or equal to x. Now, is there another way of writing this? You could write 17 is greater than or equal to x. You could also, it means the exact same thing, you could also write x is less than or equal to 17. Those are exactly the same statements. Either is fine. They're saying the exact same things, but notice how you'd read them differently. This one you would read 17 is greater than or equal to x, and this one you'd read x is less than or equal to 17. Okay. Then we've got another one here, numbers less than 72. So same thing, that means 72 is going to be the biggest one. Now it's just less than. It doesn't say anything about it including it, so we're just going to use the less than, or sorry, in this case the greater than sign. So 72 is greater than x, or alternatively you could say x is less than 72. Okay, either of those would represent that statement. Okay, here's a word problem we'll look at together. So Chanel is going in to buy car insurance. to drive her car to and from work. The cost of insurance is going to be higher if she works farther than 15 kilometers from home. So we're going to express the inequality that represents the possible values for the distance for which Chanel is going to have to pay for more insurance. And we want to do that algebraically. So basically the value is anything farther than 15 kilometers. So we could write it as 15 is the minimum amount, which means that it's going to be the smallest, and any value greater than 15 is going to work. So we could write that as either 15 is less than x or x is greater than 15. Again, either of those satisfy the example. Both of them are examples of inequalities that work for this situation. Okay. Last examples we're going to look at is when we've got a number line going from a number line and turning it into an algebraic one. So I'll do a couple here. Okay. So remember, we've got our number line drawn. We're going to draw a boundary point on there. Okay. We'll just put a little bit of context here. Got one. Right in the middle there. And we're going to draw a boundary point that's a hollow dot and all values to the right of that. Okay, so we look at that, and first we need to determine what that boundary point is. Well, the boundary point looks like it's right in between negative 140 and negative 130. Let's call it negative 135. Okay, and the values are to the right of negative 135, which means that negative 135 is going to be the smallest, so it's less than all the other values. And we look at the boundary point, it's hollow, which means that the sign remains just a less than, not a less than or equal to. Okay. You could also write it that x is greater than negative 135. Either of those would be correct. Okay, let's do another one here. Okay, so we've got 0, do a couple ticks in here, and 1, okay, and we'll draw a solid dot here, and we're going to do values to the left of that. Okay, so again we start with the finding the boundary point. Well, what's the boundary point? It's there's 4 jumps between 0 and 1, which means each of those jumps represents a quarter. It's at the first quarter, so our boundary point is 0.25. And now we've got 0.25 is actually going to be the biggest number because we're talking about all the values to the left of that. So the biggest means that it's going to open up towards that. And we look at that boundary point, it's filled in, which means we've got to make it a greater than or equal to x. And so we could read that as 0.25 is greater than or equal to x, or alternatively, x is going to be less than or equal to 0.25. Either of those would work just fine. Okay, I think we're getting the hang of it here. I'm going to put one on here that I'd like you to do on your own to convert from the number line into the algebraic expression. Okay, so it looks like this. We'll draw our number line out here. And we're going to go put a hollow point right here and all values to the right of that. Okay, so I'd like you to convert that one into an algebraic linear expression. Okay, and then show that to me, come back to class, and we'll get some other ones for you to practice. Good, thanks.